All right, welcome to, what is this, video 3. This is our surprise video, dropping this video due to popular demand, because it seems like a lot of us still have questions about arc lengths and sector. So here I have a whole circle, right? And by circle, we're really specifically talking about that blue outline. And we know some things, and we've always known it, right? The area of this circle, that's always going to be equal to pi times r squared. But, and I should be writing on a piece of paper, so that way I don't ruin my kitchen table. The circumference, we also have been learning that for a long time. Our circumference, the distance around the circle, is 2 pi r, or sometimes we say that's pi times the diameter. But we're going to be working with r a lot, so we're going to keep it as r. So that's what we already know about our circle. But we started talking about, well, we don't always have circles. Sometimes we have pieces of circles, right? So here is a circle that I divided into some common pieces. Some of this is easy, right? If I have this half a circle, right, which sometimes we call a semicircle, that's easy to find. If we wanted to find the area of that, right, we would take half of the area of a circle, which is pi r squared. And if we wanted to find the length of the curvy piece, that's easy. That's just 1/2 of 2 pi r, because that's the area and circumference of a circle. That makes sense, right? It's a half of a circle, so we just multiply everything by a half. If we had a quarter of a circle, which does not have a fancy name, right? The area of this big slice would just be 1/4 of our circle's area. The length, the arc, right? The arc length would be 1/4 of the circumference if we had our complete circle. We can keep going, right? Here I have the quarter divided into half again, right? So that's 1/8. So that means the area of this sector would be 1/8 of the entire area of the circle, and the arc length would be 1/8 of the circumference, right? But we don't always know what portion of the circle we have. Sometimes we have some crazy different shapes. So the way that we can figure that out, let's just say I do this. I take a circle that I have, and I'm going to cut it into a sector. All right, here's my sector, right? We have a very oh no, I did get it all over the table. A very obtuse angle, right? It's bigger than 180 degrees. Let's say, because I've been working with angles for so long, I know right away that this is 240 degrees, the central angle, right? That's our vocab word, central angle. This is much more than a half of a circle, but I don't know what fraction, so I don't know what to multiply my area or circumference by to figure out that portion of it. So what we need to do is we need to figure out how much of that entire thing we have. We know that that angle in the middle can only be up to 360. So that means we have 240 degrees of 360 degrees, which if we reduce that down, we get 2/3 of a complete circle. So this is 2/3. So that means if we wanted to figure out anything, let's say our circumference, if I just bring out a random number, if their circumference is 30 inches of this triangle, of this circle, then we do 2/3 of 30 to find the circumference, aka the arc length of this portion of the circle. So that's the math that we're doing in our practice problems. What I think confused a lot of people was using this proportion where we have arc length over the circumference equals the central angle divided by 360, right? That fraction part is just saying how much of the circle do we have. So I think what might help a lot of us is using just that proportion rearrange of saying arc length is equal to that fraction of the total times by the circumference of the entire circle, which is 2 pi r. This might help a lot more people to think about it because you don't have to set up a proportion. It's not weird. We just plug it in. Central angle over 360 tells us how much of the entire circle we have. And we can have a very similar one, but the sector area, so how big, what's the area of that sector, that slice, would just be our central angle divided by 360 to tell us how much of the entire circle we have. And again, the area of the circle is pi r squared. So that will just tell us, is it a half of the circle, a quarter of the circle, an eighth of the circle, or some random number, right? If we have a random central angle size. What is also preventing some people from understanding this is when we transfer over to radians. So radians is another form of measurement where we say, here's a circle, right? Where we say one time around the entire circle is 360 degrees. But we know the circumference, aka one time around the entire circle, is 2 pi times the radius. Radian and radius are so closely related. The definition is that a radian is the measurement of an angle based on the radius of the circle. So not only is that 2 pi times the radius, the circumference, but if we were to measure that angle, sorry for it's always getting out of focus, that angle we would also call 2 pi radians, because that's how big the circle is that is subtended by that angle. So that means 360 degrees is equal to 2 pi radians, and usually we just don't include the unit there. But that's not the conversion factor we usually see. The conversion factor we usually see is 180 degrees is equal to just pi radians. Because that's just simplified, we divided both sides by 2. So for the problems on Khan Academy and in life where we have radians instead of degrees, we still do the same type of math, and you can either convert the radians to degrees or we can change our math a little bit. So let's look at one more practice problem, and let me try to get this thing to focus. Maybe if I write on it. There we go. All right, so let's say the radius here is 8, and we can say this angle here, let's say that is 3 pi over 5. And we want to figure out how big is the arc length. So here is the arc from here along the curve to here. That's the arc. We want to figure out how long that curve is. So the math we do, and let's use one of those new ones, we do the arc length is equal to our central angle, 3 pi over 5, and then the entire angle, which is 2 pi. And then we multiply that by the circumference, which is 2 pi times the radius, which is 8. So we can try to simplify this. Those 2 pi's cancel out, and we're left with 24 pi over 5, which does not reduce because 5 does not go into 24 evenly. But we can write this as a decimal, and I do have my phone on me, so let me do that. On Khan Academy, it says use 3.14 as pi. So we would do 24 times 3.14 divided by 5, and we would get approximately 15.07. And that would tell us this thing right here is 15.07 units long. So if this is 8, then this is 15, almost double the size. All right. So again, going back to these new formulas that might help us, sector area, sorry, we just did arc length. Arc length is equal to central angle over 360 or 2 pi radians, depending on which unit you're using for your angle, aka which unit was given to you by Khan Academy. Or you can say sector angle is equal to central angle over 360 or 2 pi radians times the area of the circle, or pi times r squared. So hopefully that clears some things up by just rearranging the proportion into a formula. Hopefully you enjoy this video because this is the first one I've done underneath my camera. Let me know. Come during support hours in the morning if you have questions. This content won't be on a quiz until week 14. That's not this week. That's not next week. It's the week after next. Good luck.